Um, okay, so we're going to pick up where we left off. But first, any questions? We got that quiz today. Oh, yeah. If you're paying attention, I posted the practice test answers on Canvas in the same place you found the practice test. Let me say that again for all the people that are crowding in the door right now. All right. The minute I start talking, somebody else is going to come in. Where you? There they are. There's some more. Oh my God. All right. Well, I'm not going to complain. Hey, there's another one. Hold on. Everybody just hang out. Okay. Same place you found the practice test. There's now an answer key too. And it's the first side that deals with the stuff that's related to the quiz today. The quiz today is on chapter 8, which was confidence intervals. Formulas are on the quiz, right? So again, treat the quiz like as if you were in the classroom. Take it only using scrap paper, pencils, calculators, E and T-score charts. Only use those. Take the quiz. Be honest about it. That's the best way to be ready for that final exam that I'm going to be watching you take. Any questions about anything from practice tests, from homework, from just general concepts, anything? No? Okay. All right. Okay. Hey, sweet. And we're going to go right back to where we were. Let's see. Simply because you're near me. Let me see. There it is. All right. Now you should be able to see. Turn this around. Uh-oh. Let me see. Alex. Oh, I see. Oh. All right. Yeah. You got to let me know. So if, just in general, if everything needs to get in through Canvas now, it's just so much easier to keep track of. I can use the grading thing that's in Canvas. That's really nice. So if you turn something in the email and it says it's missing, just keep reminding me. I've got to go back in. I got to find it. That's fine. It's fine. It's fine. I can see the date that you turned it in, Alex, when I go to see it. But you just got to remind me. You just got to be patient. Let's see. Bam. All right. So since there's no questions on anything, I think we got this far on this example. You guys see Canvas right now. You guys see the coyote problem? The good old coyote problem. So I like it. Thank you. What I want to do is let's just kind of catch up where we were last time. We actually started another problem a little bit before we finished this one, just because I wanted to make sure you guys were understanding the first couple steps. But we'll go ahead and finish this problem out today. So here's the idea behind this. And again, if you missed this, you probably want to go watch the YouTube video. This is going to be a really quick review. We have a claim that's being made. The claim was that the coyotes live longer if they're given more room. Kind of makes sense. Live longer than what? Than normal, which is 10.15. So in Mathish, let me just go ahead and change this. I don't have to put mu. I just put a U. Get out of there. Stop it. All right, so we can all pretend like that's a U with an extra leg, so it's a real mu. The claim is the average is more than 10.15, longer. Why did we put that into H1? See how we put that claim into H1? Why did we do that? That was insane. Why did we do that weird shit? It has, no, it doesn't. That's exactly, because it doesn't have an equal sign. That's why we put it there, right? If the statement has an equal sign, it goes into the null hypothesis, HO, the HO. If it doesn't have an equal sign, it goes into H1. Cool, I like it. And wherever I put the damn thing, the other one is the opposite. It just represents the two stances on an issue. Okay. Um, this guy, the reason we do that in this problem is just so we always look at H1 for where evidence is going to be. Where's evidence going to start? Since H1 won't have an equal sign, it is the statement that I can show evidence for. We talked about this before. I cannot show evidence of equality. That just sounds so depressing, but I can't show evidence that something equals something by taking a sample. I think it's 8. I took a sample and got 8. That don't mean shit. The mean could be 9. I don't know. The sample mean doesn't have to equal the real mean, but it can be so far away from what somebody thinks it is that it's evidence that it isn't what they thought it was. That's the idea. Okay, all right. Here we go. So I know that the evidence has to start up here because it says greater than. Where does a sample have to show up in relation to 10.15 to be evidence that it's bigger? It's got to show up way above it. So my sample would have to show way up here. So again, I really want you guys to get this. Since the HO is the one that has the equal sign in it, the HO is the one that thinks it's in here somewhere, right? So if I'm sitting there and go, I think it's equal to this, then I want it to end up being close to what I just said. I think that guy over there is 60. I want his age to be somewhere close to 60 because that would show that I was right. If he turns out to be 40, I'm like, I'm really sorry. You've had a rough life. I was really off. I'm sorry. Right? You guys a little bit with me? So the HO will always be the one that thinks it's in here somewhere because it's always the one that has an equal sign. So how do I show that that stance is wrong? I get a sample that is away from that. In this case, I specifically want greater. So if I get a sample that's up here, that's showing that whoever thinks this is most likely wrong. Is it proof they're wrong? No, because a sample could show up here, right? But it's very unlikely that it would if that was the real mean. So if I do get a sample there, it's evidence that that's not the real mean. Woo! Okay. I will be coming in with some shortcut ways to think about things, but I always want to start with the full concept, right? Okay. Now, so the first step makes sense. What the hell are we talking about? You got to set up what it is you're talking about. What is it you're testing? Okay, that makes sense. Part B makes complete sense. All right, before you do any stats, are you allowed to do stats, right? And if you're allowed to do stats, what kind of stats? Z or T? So that's the second step. So first step, what the hell are you talking about? It's got to be the first step. Second step, why are you allowed to analyze what you're talking about? Okay. So that was, in this case, the sample size is big enough, right? Central limit theorem says all good. Your means will be normally distributed. And we knew sigma. It says population standard deviation. We know sigma, so I can use z-scores. So again, I always get people confused. Remember this. Why were t-scores invented? Because in the case that I don't know sigma, in the case that I only have an estimate, S, I don't have just an estimate. I know what sigma is here, so I don't need t-scores. They don't need to be used. I like it. Okay, maybe. You guys got to let me know if you have a question. I'm just going to kind of like keep going because I want this. We already did this work. I'm just trying to catch everybody back up. So then the rejection region is going to be where evidence starts. So again, what I'm doing now, everything I talked about up here with the what is that, fuchsia? I don't know. The blob here, everything I talked about up here, I'm going to formalize on this step right there. Where does it start? Where is far enough away from the middle to say that the null hypothesis looks wrong? He's the one that thinks it's in the middle. So that's the 2.326 we found because alpha was 0.01, right? Just to catch everybody up. Alpha was 0.01. It's a one-tailed test, and I can use z-scores. So how did we find 2.326? We, of course, used the t-score chart. I disappeared on magic. Let me turn off my background. I don't know how to do that. Oh, here we go. Okay. Otherwise, all right. How did I do that? Use a t-score. So nobody's asking questions, so I'm going to assume everybody's with everything I've said so far. You might be a little confused as to why we just said we could use z-scores. Why am I looking at a t-score chart? Because z-scores live at the bottom, right? Right? Not in a pineapple. So alpha is 0.01, one-tailed test. That's the second point, not two, right? Alpha is 0.01, one-tailed test, z-scores. Alpha is 0.01, one-tailed test, 0.01. So I'm in the second column. I go all the way to the bottom. I don't even know if I'm pointing to the right thing anymore. There it is, 2.326, all the way at the bottom. So with this chart, if I stop, I get a t-score. If I go all the way to the bottom, I get a z-score. Okay, I like it. Still don't see anything. So I'm an optimistic fool. So that means everybody's with me, and it doesn't mean that everybody just went back to bed. Only in the bottom row. Yes, exactly. Because again, I don't know if I said this. This is even harder for me to keep track of because I have two stats classes, and I'm like, did I say this to this class or the other class? Why do we need t-scores? For when I only know S. When does my estimate S get better? When I have a bigger and bigger sample. Do you see how the t-scores get smaller and smaller as my sample size gets bigger and bigger? Yeah, when they get large. You gotta love that shit. Can you be more specific? Large. Oh, okay. So yeah, when the sample size gets large, and it's really open to the situation. That's why they make it kind of vague. Depending on the situation, you could define large to be different things. But when the sample size gets large, I don't need t-scores anymore because then I feel really good about my S. I say it estimates sigma well. If I take a big ass sample, I'm going to feel pretty good about the X bar and the S that I get. So therefore, anything that's supposed to cover my ass for not knowing the real standard deviation, I don't need it as much. In fact, when it gets large, I don't need it at all. I could just use z-scores. Okay, hopeful Tai Chi. So that's why we did all that. So there's 2.326. That's where the evidence starts. So HO thinks it's in here. If I get a sample that's out here, like we did, then that shows that I can reject the null. So if my Z, let me make this, I don't know why I did this. If my Z star is greater than this, that means I'm so far away from what the Ho thought, the null thought the mean was, that it must not be that. It must actually be bigger. So what we did, we did part D. We actually calculated the Z-score. Right? There's my, I just summarized everything I knew. This step freaks people out. Let me see if I can't draw this. This is this step here where you figure out the new, all right, the new, crap and a half. It's so hard to do this. Oh, Jeff, you could do it. Come on. The new sigma, remember this? Sigma X bar? Oh, that's disgusting. That is sigma. It got into a bar fight. I don't know what happened. I gotta try that again. Let's see. Can I do it up here? Is it gonna let me do it? Oh, you have to pick the right tool, Jeff. Disappear. 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 What's going on? Give me a second. I'm fighting with this. Come on, you can do it. All right, all right. Why won't you draw normal? I just can't do it. All right, screw it. That's the sigma x bar, right? The sigma divided by square root of n. I appreciate you getting a kick out of that. Okay. So it's the old standard deviation divided by the square root of the sample size. And then we got the z-score. Z-score formula is the same. It's the same old z-score formula. It's our data, 12.45. And here's the thing, minus the middle. The whole thing about hypothesis test is we're assuming that this number really is the middle, and then we're trying to see if we get a contradiction. Well, people are coming in now. All right. Anyway, so we did the same old z-score formula, x bar minus the mean divided by the new standard deviation. We've used that formula before, right? So you've got to identify what parts of this problem are old news. Not everything here is new. In fact, very little is new. A lot of it's old news. And since we did, oh man, people are still coming in. All right. So 3.45 is definitely bigger than 2.326. So our sample was almost 3.5 steps, standard deviations away from 10.15. That is pretty good evidence that the real mean is not 10.1, it's actually bigger. Does this mean the real mean is 12.45? Of course not. That was my sample mean. The sample mean could be anywhere. But the fact that it was so far above 10.15 is good evidence that the real mean for these coyotes that got more room is bigger. It does seem they lived longer. Now, some people, I think I've said this before, some people might say, why did you do all this flipping work, Jeff? Holy shit. 12.45 is bigger than 10.15. We knew the answer. No, you didn't. No, you didn't. So it all depends on how far away that is. If I ask you, is 50 very far away from 52? Your answer is, I don't know. Because until I tell you what the spread is, you got no idea. If the spread was 0.03, 50 and 52 are crazy far apart, right? In fact, 600, I think there's 600 standard deviations apart. Hopefully, if I did that right, man. No, I did it backwards. Screw it. 100 and something. There, whatever. That's fine, Jeff. It's freaking huge, right? Okay, maybe. I know there's a lot of steps. I know. All right. So let's finish this one up. We did all those steps before. All right, so let's finish this up. So what can I say? Did we find evidence? Yes, we made it into there. Remember that line right there is where evidence starts. So did we find evidence? We sure did. Right, so we have found, holy macaroni, that's fine. We have found, have we? We have found sufficient evidence to, now we got to figure out to do what? Malik, are you okay? What's going on? Oh, is that from earlier? I don't know. Somebody's saying no. Okay. Blah, 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 blah. We have found sufficient evidence to do what? Right here, we wrote this down already. I know I can reject the null. I can support the high. There's no confidence interval here. I'm not sure what that means, Alex. I'm sorry. Let me see. Remember this? We made it into the rejection region, so I can reject the null, because that's the one that thinks it's in the middle. So we can reject the null, which means I can support the other guy. If I can say this guy's full of shit, I can say this other guy seems to be okay. Which one of those was the claim? Which one was the claim? Was it the HO or the H1? Which one was the claim? Yes, I mean, that's where we put the claim, right? We put the claim into H1. So how do I want to word my conclusion? Probably based on what the claim is. If somebody says, can you test this claim for me? I got to come back with them with, well, here's what I found about your claim. So the conclusion, we have found sufficient evidence to, I'm going to use this language right there because the claim is H1. We have found evidence to support the claim. The claim that, and then, and now, just to placate my English professor, let me say this. I like my hair. All right. Plagiarize this one time because I got to talk about the claim. So what the hell was the claim? We have found evidence to support the claim that the northern Minnesota coyote lives longer if given more room to roam. That the northern Minnesota, oh my gosh, coyote lives longer if given more room. Okay. I like it. Holy shit. So 5 parts to this. You got to make sure you understand each part, right? And the homework, 9.1, 9.2, 9.3, 9.4, they kind of break it up into each part. And then 9.5 is where we get whole problems. Let me say this again too. I'm pretty sure I said this. The book references a worksheet to use for the hypothesis problems. Screw that worksheet. That worksheet assumes you're doing all the work in the calculator, and we are better than that shit. You're going to use this template. You're going to use these 5 steps, right? You better, or else you're screwed. All right. Let me see. So, and look at this in another way. Just look at this. Just look at this. The middle is 10.15. We got way the shit up there. So of course we say, it looks like it's more, right? Just on that level. Here's the 10.15. We think it's more. Here's 10.15. Our sample got way the hell up there. It looks like it's more. Isn't that what our conclusion says? We found evidence to say it's more. And then you fill in the details. We found sufficient evidence to support the claim that the northern Minnesota coyote lives longer, more, if given more. Oh my God. Okay, let's do this. Let's do this other one. Uh-oh. Did I freeze? Okay, I'm back. Okay, I don't know. Let me know if it's been good for a while. Oh, Reed, we're going to come back to the p-value in a minute. All right, I've already overloaded people with too many things. I know, and it's sort of like the best way to do this. I'm going to come back for the p-value in a minute. Okay, thank you. Don't worry about the p-value yet. We got enough to worry about at the moment. The p-value is an extra thing. It's really important, but it's not necessary right now. We'll come back to it. So this side, all right. Hopefully, well, you guys can all see it if you don't have it. We did this map. We did this work here last time. We did. So remember, the claim was in the second sentence. We visit a plant to see if their assembly time is the same as the overall average. So the claim is their mean is 38, the same as everybody. So we want to see, are these people better or worse at this plant? It's sort of like a quality assurance, right? QA. So of course we put that right here. Why? Why did we put the claim next to the hoe? Yes, it's got an equal sign. I love it. Kick ass. Beautiful. And then the other one was blank, so we just put not equal to. And I think somebody had a good idea. I don't know, what was it? Not equal to. Okay. Thank you. Or the other way around. Okay. That would be the ultimate, is if I could make real symbols in this, I would have everything I need. But, you know, I've learned, kids, to become cynical about things. All right. Now, let's do part B. You guys do part B real quick. Part B is old news. You've done that kind of shit before. Don't write anything in the chat yet. I don't think we did part B last time, but if we did and you were here, you already know what the answer is. Let's see, while you guys are doing that. Oh yeah, that's right. I got another side to this. That's right. That'll work. Ba-da-boom. Okay, let me check in with you guys. Two things you have to say here. First, most important thing is, why can we do anything? Let me keep my color scheme sort of the same. Yeah, how do we know it's normal? CLT, that's right. Sample size is 71, which is greater than 30. So central limit theorem says go to town. I like it. It's either got to say it's normal or the sample's got to be bigger than 30. Now, in the homework or on a quiz or on the final, if you don't think it's normal, say so, but still do the problem because you are wrong. I'm not going to put, now listen, I'm not going to put a problem where only those people that notice it's not normal don't have to waste time doing it. Do you understand how evil that would be? So you could miss something, you could not notice some part of it. So just say, I don't think this is normal, and then still do it. That's fine. Okay, maybe. Okay. Just be careful. And what's the second thing now? Now I know I could do something. What can I do, Z or T? Yeah, Z scores again, because we know sigma. Just to remind you guys, just in case you forgot, sigma, come on, you could do it, Jeff, looks like that. I'm still in fuchsia. That's all right. Don't come at me if you know that's not fuchsia. I don't know what the hell it is. All right. So we're allowed to use Z-scores. Awesome. No. I just want to circle this. No? All right, fine. We just want to use Z-scores. Okay, now, up here, I forgot to mention, we drew this. It's a two-tail test. Why? Why was it going to be a two-tail test? Anybody? I'm just typing stuff down. Yes, exactly, Alex. To show evidence for not equal to, you can show bigger or smaller. That's why it's two tails. So the number of tails is where the evidence could show up. The last problem we did, we thought it was greater. That's the only place evidence could be then is above. This one is not equal to. It could be either direction. And that's, again, why the T-score chart kicks ass, because it's set up for both kind of tests, one or two tail. And why am I going to use the T-chart here? What the hell, man? We're going to get Z-scores. Yeah, sorry. It's my little skit, and C. So why are we going to use the T? Because Z-scores are at the bottom of the damn thing. So if I look at two-tail, 0.05, right in the dead center. So look at this column. This is not easy to do. And I get to the bottom, and I get a Z-score of 1.96. So let me see if I can't draw a better normal curve here. All right. Okay, I can live with that. Get in there. I'm gonna have to lift this whole thing up. That's fine. Okay, rise. Okay, now. So what did we just get? 1.96, right? So this is what's on this side. Yes, negative 1.96. We're the humans. We have to put the negative in at the right time. And then this side, 1.96. So in English, what's the rule here? Let me fill these in. There's my rejection region. Let me do it. I'm going to make it work. There. Get out of there. Okay. That is my rejection region. And again, you got two levels of this. You've got the technical terminology and all that kind of stuff. And then you got just what the shit makes sense. How can you show that this guy is wrong? He's the one that thinks it's in here. Well, I just get out. I just get away from what he thinks it is. So that's what the rejection region means. When can I reject the null hypothesis? When the sample shows up so far away from what it thinks it is. That's it. So if my sample z-score, so if my z star, that's just the sample z-score, is less than negative 1.96 or greater than 1.96, then of course we can reject the null because the null thinks it should show up in here. We can reject the null, support the high. So I know it's got several steps. If you just focus on each step, no step by itself is really that difficult. The first step is kind of new, but it's just consolidating what's going on. The second step is not new at all. Part B, old shit. The third step is a little new, but we've done this kind of thing before, right? We've used alpha, we've done that kind of thing before, and it's not too hard to use the t-score chart. And then step D is old news. Just make a z-score. So what do I know from my sample? What was my sample mean? Let's see, it looks like it was 37.3, right? So my sample mean, my X bar was 37.3. I know sigma, oh, screw it, Jeff. I'm not gonna try to draw it. Sigma, what was it? 2.25, thank you. I know N, becoming N. I forgot, 71. So of course, before I make a z-score, what do I have to do? New standard deviation, exactly. So let me see. I'm not gonna, new sigma. This is the sigma sub X bar. All right, let me try. Oh, yeah, Jeff. Yeah, that's all right. That's fail before you even start, buddy. Hey, look at that. Okay. Small victories, right? Oh, dude. Oh, shit, yes. Sorry. It's an interesting world we live in now. What makes me happy? All right. Come on. There we go. Look at you go. Get in there. Equals. So it's going to equal the same old formula, the old standard deviation divided by the square root of n. That should definitely be old news. I don't know what you get. Let me see. What's it going to be? I don't know. 8, 9. Screw it. I'm not going to even. Yeah, it sounds about right. Whoa, I got some computers there. Let me see what I get. Square root of 71. I get 0.267. Yeah, so redo that. That's all right. We all mess up sometimes. So 0.267. So you, again, so the whole thing really is, the more comfortable you were with what we did in chapter 6, in chapter 7, the easier several of these steps will be. This step is completely old news. I'm just going to make a z-score. I just happen to call it z star. You just deal with me. So it's going to be, it's always the same formula. It's our data, 37.3, minus what the middle is. We're assuming the middle is 38, right? Divided by the spread, which was 0.267. Let me see. 2 2/3. 3/8, 0.7 times 3/8. I don't know. What am I trying to do? Oh yeah, it was 7 divided by. Somebody saved me. Thank you. All right, jeez. Stop trying to do that, Jen. It's too early for that shit. All right. All right, negative 262. What the hell does that mean? Let me make it in red. Now watch. Let me. Where does that go on our picture? Can you see where it is on the picture up here? Where's negative 262? It is way down here. Right? It's in here. No, you're going to let me do this. You are. Oh, gosh. All right, let me see. Come on, I could do this. You're not better than me, computer. I'm going to do this somehow. I'm going to make this big. Yeah, like that. Yeah. All right. Sorry, I'm going so loopy. It's insane. All right. There. Okay, become a thing. Yes. All right, sweet. Let me stop. So again, the HO thought, excuse me, it would show up. Oh my God. Egads. All right. That's why I'm not a podcaster. Hello and welcome. The HO thinks it's in here, thinks it's equal 38. We just took a sample that got way over there. Whoever thinks it's in here looks to be wrong. It's evidence they're wrong. Why isn't it proof they're wrong? Because there is a chance that a sample could show up out here, even if that's the right mean. There is always a chance that we're wrong, even if we did everything right. And that is so beautiful because that's freaking life. Yeah. People want to discount stats because it can't tell you the exact answer, but holy shit, of course it can't. But I feel really good to be able to say it looks like that's wrong. So what is your conclusion? So again, we did make it in there. If this, watch this cool shit I could do. If that had been over here, oh, did I sneeze? I'm sorry. If I sneezed, I didn't even realize. Oh, Laurel sneezed. That I didn't see. Okay. I was like, did I sneeze and not even notice? So if my Z star had been there, we would have failed to find evidence. But it was here. So we have, let go. Okay, we have found, start typing. What happened? All right, what are you doing? All right, we there have found, I don't know what the hell, sufficient evidence to do what? I should have put it up here. I'm really sorry. Let me go back up here. Go there. All right. My God, why is everything so slow? Come on. Okay. Right here, right there, I can say, I can reject the null. Why? Because look at what I wrote in English up here. Look at this statement right there. If Z star is less than negative 196 or this, we can do these two things. So I can do those things. I can reject the null. I can support the high. Now down here, when I do my conclusion, get in there. Okay. What language do I want to use? What was the claim? Was the claim the null or the high? The claim, of course, was the null. Yeah. So then what language do I want to use? This language. Right? In fact, no, screw it. I'm not even going to try. I want to use that language right there because that's what the claim was. We have found sufficient in here. United States. Okay. We have found sufficient evidence to reject the claim that, all right, plagiarize. Certain Ford plant assembly time is the same. That the plant's assembly time is the same as the overall average. In fact, we could be a little more specific. Does it look like they're doing better or worse than other plants? Looking at where our sample ended up. Do they take, yeah, they look like they're doing better because it takes them less time. Now, the next thing I would do is look at the quality of their output, right? If they're taking less time because they're making shit cars, that's a problem. All right, so you're gonna have to forgive me. And you're like, that's all we do. Oh, I should not have done that yet. Let me keep that up there for a minute. All right, you guys finish copying whatever you need there. I need to erase the shit on the next page because I want you guys to do the problem. I did that yesterday with my other stats class. Get in here. Where are you? Dadgummit. There you are. Okay. You guys got that? Let me see. Anybody still need that up there? Is there one constant formula? No. So Malachi's got a good question. Now, I will claim, and rightly so, that you use the same z-score formula all the damn time. It's your data minus the supposed middle divided by the spread. That's what it always is. The details of each part will be different. We're going to do a hypothesis test for proportions. P hat, Q hat, all that kind of shit. So the z-score formula, you would say it's different because it's going to have p hats and p hat, q hat over n and all this weird shit in there. And I'm going to say it's the same. It's my data minus the middle divided by the spread. It always is. So that's a good question with unclear answer. Depends on your perspective. All right, I'm going to assume everybody's got that stuff. So you are going to give me an unfortunate amount of time. I'm really sorry. You guys, if you formulate any questions, put them down in the chat. It's really disgusting how long it takes me to undo stuff that I've done here. Oh my God, help me. How's everybody doing? Hey, I know what I'll do. Let me try this. You guys are gonna love this. You know when I say that, you're probably not gonna love it. All right. So when you get a link on the screen, click it. And you're gonna talk to each other, little groups, just to check in, say hi, and to say how much you hate what I just did, right? All right, here we go. Go. Click the link. Click it. This way I can tell who's not really here, who went back to sleep. If you're back in your room, come back. I'm making you do something. There's a couple of you there. Okay, there's everybody. Sweet. Who's asking me for something? I don't know. Hopefully nobody. All right. Whoa, that's so funky delic. Yes, you've returned. Thank you. Not everybody has. They like it where they are. I understand. There's some people, let me see, they're going to be forced out of there in a minute. Well, there's a whole breakout room. They really like each other. They're like, screw this guy. I am, I am Zoom God. I will destroy their rooms. All right. All right. 13 seconds left. Let me see. 9, 8, 7, 6, 5, 4, 3, 2, 1. Their rooms have left. Okay. That is such a weird sound. Everybody make it back. I guess if you didn't, you can't say no. So I see puppy dog. Aw. All right. So let me share my screen. What do you guys think about that experience? You guys all right? Did you survive? Did you just go there and just sit there and just say, when's this going to end? I'm thinking about trying to use that to do some group work kind of stuff. Yeah, good to talk to people. Yes, yeah, so that's what's missing for you guys is you listen to me all the damn time, but you're missing the interaction between other students. So obviously, yeah, I know, Hannah. There was 35 people, so it was either two or it was anyway. I didn't want to put too many people in there, so anyway. Um, so yeah, it sucks if you have one other person and the other person's weird. That's always different. So I was thinking about doing that for like group work stuff. So we'll see if I can incorporate that because that is what's missing is your ability to interact with other students. So let me go back to this. All right, so what I want you guys to do is to try to do the first couple of steps of this at least. Everybody see this one? We all live can everybody see the one about credit card debt? Yes, okay. So some of you guys are like, whoa, really that much? And some of you guys are like, man, I remember when I only had that much debt. Okay. So just take a minute and try to do the first couple steps. Yeah. See my hair. There we go. All right. So let me make sure if you guys are on the right step. So I don't want to bring up any bad memories, but it's just like in algebra when you had to do word problem. The very first step has nothing to do with math. Very first step is just in English. What's the claim? Somebody just came back in. Weird. Which sentence has the claim in it? First, second, third, or fourth? Yeah. What's the kind of like a few of the possible yeah, we're going to catch up to that. Let me see. A few of the possible keywords: we believe, we claim, that's a big one. We feel, we think, or somebody feels, somebody thinks, somebody claims, something like that. Those kind of words will point out what the claim is. We believe the debt has decreased from 906. So what rewrote is right. Rewrote the right thing. I like that phrase. So in Mathish, the claim is mu is less than 906. So where's that going to go? All right, keep going. Do the first two steps at least, A and B. Why do I have a Hanson song? I got MMMBop in my head, but this shit. MMMBop. All right, let me catch up to you guys. So you said to put that here. I like it. You could have just copied it, Jeff. It's all right. It's not that much to write. Okay, Jeff. And the other one's got to be opposite. What's the opposite of less than 906? Don't say greater than 906. That's wrong. What's the opposite of less than 906? Yes, greater than or equal to 906. I like it. Right, together they're supposed to cover everything. So one of them's got to include 906. All right, let it go, Jeff. Will this be a 1 or a 2-tail test? Definitely a 1-tail test, because right there, H1, the only way to show evidence for that is if it shows up below 906. So it's a 1-tail test. Okay. What do you guys get for part B? Anybody got that? What's the 2 things you got to check? What's the very first thing you should check? Check, check, check. Yes, so the first thing you check is it normal? N is 81 greater than 30. You got to be careful, Lewis. You got to be careful. I always get somebody that says, I can use z-scores because I know the standard deviation. That doesn't make a damn bit of sense. How many standard deviations? There's 2 for these kind of problems, for means. There's the sample one and the population one. Where did that standard deviation come from? Yes. That standard deviation came from the sample. So you do have to do the slightest bit of detective work. Did I say that it's a sample standard deviation? No. But if you read the statement, from a sample of 81, we find this with that. Okay, those both came from the sample. So that standard deviation is S, it's not sigma. So therefore, I need the thing that was invented for that situation, which is t-score. So don't know, okay, that's not the word no, Jeff. Don't know sigma, only S. Therefore, we use t-scores. Because that's why they were invented. How much time do I got? Okay, I got enough time. I can sneak this in here. All right, somebody see what alpha is? Sometimes I put it here and sometimes I put it in the problem, so just too bad, you got to find it. So alpha is 0.01. I know it's a 1-tail test. Don't number these, Jeff. Alpha is 0.01. It's a 1-tail test. I know you want to use t-score. So what's the degrees of freedom? Degrees of freedom. Can't be negative, Lewis. Got to be careful. I know what you mean, though. It's below, but it's a positive area. Yeah, degrees of freedom is 80. Okay, stop it, Jeff. That's so culturally insensitive. All right. Where am I at? There we go. So look it up real quick. Don't type it out yet. Don't type it. Don't type the answer yet. Do not type the answer. Look it up. See if you can find the t-score. Don't type it. There's always that one kid in class. I'm like, don't say it. Don't say it. 5. Oh, no, don't say it. So remember, yeah, this is a t-score. All right, let me see. Who's found it? Anybody found it yet? So we got a 1-tail test, 0.01. So I'm in the second column. And if I go down to 80, are you going to really try to do this, Jeff? Sure, why not? Go down to 80, 2.374, yes, 2.374. So if you stop at the degrees of freedom, you'll get a t-score. If you don't stop, you'll get a z-score. Ain't no party like a z-score party, because a z-score party don't stop. So let's see. My t-score 2.374, is that right? Yes. Maybe? I don't remember. Is that right? 2. Yes. So if I draw this sucker, and of course it's not 2.374, is it? Let's back up for a second. Why is it not 2.374? It isn't. Let me draw it and I'll show you why. You can do it, Jeff. Okay, that works. Because the tail's going to be down here, right? How do I know the tail's down there? Because less than, correct? So it's not 2.374. What is it? Can't be 2.374. Yeah, it's negative. Good. I like it. Negative 2.374. Bum, 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 bum. Allow me to do things. Allow me to do things. Okay, there we go. So let me see if I can do this. So you always want to shade in your rejection region. So it kind of makes sense to show evidence that it's not here, that is less, my sample's got to show up in there. So I want you to do it in words also. Use your words. If T star, I know, it's a t-score now, right? If T star is less than that, what can we do? Oh, why is it negative? Because are you cool with the tail being on that side? Because this is less than, right? So the sample's got to show up below 906. And since it's below the mean, it's negative. We know that already, right? So this side in the middle is 0. This side's negative. That side's positive. Is that cool? We've done that kind of thing before. We're the humans, we got to know where the negatives and stuff are. Okay, all right. So if T star is less than that, we can reject the null, support, not the high that way, Jeff, sure. The alternate. Get over there. No! Why won't you let me do it? All right, I'm not going to try to do anything. Step away from the computer, Jeff. All right. Got like no time left. Damn it. What do we got? You got 2 minutes. Okay. So let's summarize what we know. What was the sample mean? X bar. 880.34. I like it. Stop it, Reed. Don't give anything away. We haven't gotten there yet. X bar. And here's the part that people really trip out about. S, what was S? 106.25. You're okay, Reed. I'm sorry. I didn't mean to be so mean. 106.25. N is 81. No? Okay. N is 81. There you go. Here's what people really trip out about. I still have to do the new standard deviation. Of course I do. Of course I do. I don't care that it's S. I don't care that it's S. S and sigma are the same thing. They just talk about different groups. S and sigma are standard deviations for individuals. I need the standard deviation for groups of 81. Therefore, I have to change it. I have to make this the new standard deviation. It's the old one divided by the square root of 81. All right, so I think, unfortunately, I'm going to have to officially stop there because it's already 10 o'clock. Unless, has anyone got to leave? You want to finish this out real quick? If you got to leave, just chat. Just tell me you got to leave, but let's just keep going. Let's try it real quick. Just hang out with me. That divided by, yes, sir, divided by square root of 81. That's going to be 11 point, thank you. 11.810. Because remember, standard deviation's got to be at least 3 places, right? Is it 11.810? You got to make me get my calculator out? Don't make me get my calculator out. 11.806. Okay, there we go. All right, so now to do the T star formula, don't freak out. T and Z are basically the same thing. Same formula. Our data, 880.34, minus the supposed middle, 906, divided by the new spread. Let's see what we get. I'm going to try to do it in my head. 2.4 something? 11.816? Damn it. Is it? All right, hold on. I got to double check the... No, it's 806, Malachi, but thank you, though. Negative 2.173? Yeah, good try. Thanks for playing. Yes, a few people got that same thing. So this is kind of exciting. Look, did we make it? Did we make it far enough? Maybe it's only exciting for me. I don't know. It's probably only exciting for me. Did we make it far enough? No, we sucked. We got right here. Do the last thing. Okay, God. Okay. We didn't make it. We didn't make it. This is the first time we didn't make it. So what do I say right here? Did we reject the null? Nope, we failed to reject the null. Reject. Which means we failed to, all right, what happened? Computer failed to support the high. We didn't make it. We can't say the dude that thinks it's in the middle is wrong because we basically got in the middle. So the conclusion would be we have not found sufficient evidence to everybody cool with that? We didn't make it in. So we have not found evidence. To do what? All right, the claim was the high. So I'm going to use this language. We have not found, failed, we have not found sufficient evidence to support the claim. No, Jeff. That plagiarize. Mean credit card debt for college students has decreased. All right, I think that's plenty. Oh my God. Thank you for that. It's nice to finish that bad boy out. So don't forget, I'm gonna make the quiz active the minute that I close this up. So you wanna jump in there and get that sucker going. You have until 11:59 p.m. tonight. Maybe don't try to turn it in at 11:58. I mean, if you turn it in at 12:07, I don't care, man. I just want it in there when I wake up. But please get some sleep, all right? Okay, anybody have any questions? Need to hang out for a bit? I guess not, okay. I'm gonna shut this down. Let me see. I'm gonna stop sharing. I don't like sharing with everybody. All right, so if I don't see any questions, I'm gonna go ahead and shut down. No, and then I'll make the quiz active. All right. Bye, everybody. Be good.